Problem 8.32. Plot the function f is equal to e to the 1 over x divided by 1 plus x when x is different than 0 and 0 when x is equal to 0. And discuss how many real solutions have this equation. Okay, equals to x3. Now, okay, so let's see. This obviously, so we know that e to the 1 over x has to discontinuity at 0, right? And we know that when this goes to 0, this is from the left, this is 0, and the limit when x goes to 0 on the right of this function is going to be plus infinity, right? And then we know that 1 over x, sorry, 1 plus x, the limit when x goes to minus 1 on the left is going to be minus infinity, and the limit when x goes to minus 1 on the right is going to be plus infinity, right? Now with this information, and knowing that this is only going, the denominator is only going, sorry, the numerator is only going to be 0 at 0, but this is never, so it's not exactly, it's not defined at 0, but here it gives us this solution. So it only has this root at 0. It's an avoidable, well, half avoidable discontinuity, right? Now it's defined at 0, this function, right? Now what happens, we have this asymptote here at minus 1, right? This is x minus 1 and this is x equals 0. So let's see, after x equals 0, right, we know that this function 1 over x is going to be like this. So after this is x equals minus 1, right? After x equals 0, this is small, right? This is smaller than 1, but this is still so this is like multiplying something that is going to plus infinity by something that's smaller than 1. That's still plus infinity. So this is like this function after the asymptote is like this function, but kind of brought down to the 0. So it's going to go like this. Okay, you know that the limit when x goes to infinity of this is going to be 0, right? So like this. And then between 0 and minus 1 we have this, right? And we know that this is going to be positive, but small, right? Okay, so now the limit when x goes to minus infinity of this this function e to the 1 over x, we know that this goes like this. When x gets very large, this is e to the 0, right? So this is an asymptote here at 1. So it goes like this, okay? And from here it goes like this, but from below, right? When x goes to x very negative, this becomes 0 from negative values, so something like this, right? Okay, so we have that between 0 and minus 1, having this, we know that x is going to, e to the 1 over x minus x is going to be between 0 and 1, okay? So you're multiplying this thing, which is very large, by something that's between 0 and 1. So it's going to be, not going to change anything in the function except, sorry, in the qualitative behavior of the function. You're going to get something like this, okay? You're still going to get to plus infinity here. And then when you go to, from this to the left, you start at minus infinity here, right? And then this is also multiplied by a number that's between 0 and 1, so it's just negative, like this, okay? So that's the function here. Now the last question is, how many real solutions has the equation f equals x cubed? Well, you have this is x cubed, right? So you have two solutions here, one positive and one negative, and then you would have, this is not a minus 1, sorry, okay, just in case, this is just a negative solution, and this doesn't have a solution at 0 because this is not defined at 0, okay? But if you defined f of x equals x cubed, then you would have the solution x cubed at 0 as well.